Hello, good morning. This is Tehmina Khan, TK. In this video, I'll explain you the differentiation of quotient function of polynomial. In the previous video, I have covered product functions, product of two functions, and now quotient of two functions. On the top, you can see the blog address on which I have put the link of all my videos so that you can easily access to it, to the one you need, and I'm keep uploading or updating the new videos which are requested by students. So let's start the differentiation of quotient of two functions of polynomial. I have taken 4 examples in this video from the exercise 15.4 of AdMaths book, which is like 99% used in most of the school to cover the syllabus of additional mathematics. So by quotient rule we mean when the function is given in the form of u over v. So you need to differentiate it by this method, right? So you will get the differentiation of the quotient rule, quotient functions by this formula. These are the notations of differentiation. You can write y prime or dy over dx. Okay, so the formula is v square. So whatever the function is here, you will square it. And then in the numerator, which is this, you will write function of v as it is, then the derivative of whatever the function is here, I mean by differentiation, and then minus this function u, and then the derivative of this. So this is the formula we will use to find the differentiation of the quotient rule. Let's take an example so that we can understand better. Okay, so for example, the function is 2x cubed divided by 1 minus x. So this is my u and this is my v. So I'll find out the derivative of each separately so that I can plug in this formula. So the differentiation of u is 6x squared. I'm repeating, 3 multiplies by this and then 3 subtracted by 1. We have seen that before. So we know the basic differentiation of polynomial. If you don't know, you can see my other video in which I have explained the basic differentiation of 4 functions, which are polynomial, trigonometric function, exponential function, and logarithmic function, because these 4 functions are the part of our syllabus here in O level and also in A level mathematics pure. Okay, so my v is 1 minus x. So differentiation of v will be 0 minus 1, which is here. So now I will plug in these values here, and that will give me the derivative of this function. So now I'm simply substituting the values here, you can see, and then I will open the bracket, I mean expanding the algebraically, and then I will simplify it. Like terms will be added or subtracted. These two are like terms, so minus 6 plus 2 is 4, so I'll simplify it. And after that, if you see that you can further factorize numerator, do so, because we write in the simplest form, and simplest form is always the factorized form. So now you can see I have simplified it. This is my derivative of the function we have seen above, which was 2x cubed divided by 1 minus x. So this is the derivative of the function. So let's see another example. Okay, so now the function is x squared divided by 1 plus x power 2. And I have to find dy over dx, or the first derivative of this function. So I'm writing down the formula again here, which is v u prime minus u v prime over v square. So now this is my u and this is my function v. So I will differentiate both of them. Here I have taken it. And now I will differentiate both of them and then plug in the values there. So now I'm assuming at this stage that you know the derivative of the polynomial function, because I have explained that very well in the previous 2 videos in detail. So now I'm substituting the values here in the formula, and then I will simply expand it. Now you see, what was my v? 1 plus x whole square. So when I'm writing here in v square, this will become power 4. Can you notice? When I'm writing here x square, it will become power 4. And numerator, I'm simply expanding it. You can see algebraically I'm expanding here, multiplying by 2. This I'm keeping as it is right now. Why? Do you think why I did so? Because I can see the same term is existing here. So when I will factorize, or I will take common factor out, I will take 1 plus x common out. And why will I do that? Not only because it is common, also because it is present in the denominator. So it will help me to cancel out and simplify the term. So you can see I did not expand this. I have only rewritten it. I have brought 2x here. So now from this term and this term, the common is 2x 1 plus x bracket, right? So I have written here the common factor. 2x 1 plus x. 2x is here, 2x is here, 1 plus x is present in both places. So now once I have taken the common out, what is left from this term? Only 1 plus x, which I have written here, minus, and what is left from here? 1x, because I have already taken out 2x 1 plus x. So after simplifying it, now I will cancel it, because all three terms, the brackets and this, are multiplying, so we can cancel it out. Sometimes a student make mistake and cancel with this one. You see, they say, oh, it's same thing, cancel it out. But what is the problem? This bracket is considered as one term, right? So whole of it you can cancel if possible, not what is written inside and it is with plus or minus sign, right? So you cannot cancel that. This is a basic algebraic rule. Okay, so after cancelling, now you have 2x here, and when you expand it, these x's will cancel out. So this is what you will be left with. So this is your differentiation of the function. And now here I will tell you something very interesting about this function, because students usually find the quotient rule little difficult. So what do? They change the quotient function into product function. I'll show you how. The same example I will solve by the product rule now, okay? And we will get the same answer. So whatever you find easy, apply that method. There's no harm doing whatever you like. Okay, so here you see, this is a quotient rule, u over v. So if I apply law of indices and take v in the numerator, it will become v power minus 1, right? So I have changed the format of the quotient function into product function. So now, if this is my question, okay, and I take 1 plus x whole square in the numerator, it will have power minus 2 then. So now this is my function u, and this whole is my function v. Now here students make mistake at times. They think it is function v minus 1. This whole is a function v, remember it, okay? So now, because I have changed this question into product rule, so I will apply the product formula, which is uv prime plus vu prime. So now my function ux square, this is my first function, this is my second function. When I differentiate it, it will become 2x, right? And this is my second function, which is this. When I will differentiate it, you know, this is in a form of a composite function. So minus 2 will come here as a multiplier. Function will remain as it is, and then power will be subtracted by 1. And then you will multiply by the differentiation of the function given inside, the expression given inside. So the differentiation of 1 is 0, x is 1. So now I am simplifying it. So this is what I will get. No problem. So now I have u, v, u prime, v prime. So now I will simply plug in the product rule. Okay. So here I have substituted the values in u. You can see u, v prime, because this was my v prime, plus v. I took this as my v, so it is here v, u prime, which is from here. So I've simply substituted the values in the function, and now I am simplifying it. I'm multiplying these two, and because it has power negative, I'm taking it in the denominator. So this is a simplified form. And now you will take LCM, So when you will take LCM, you will have 1 plus x power 3 as a common LCM, least common multiple, and then you are simplifying it. This will come as it is, plus 2x, and it will multiply by 1 plus x. Why? Because in this denominator I have 1 plus x power 2, whereas here I have 1 plus x power 3. So 1 plus x, one term is less, so it will multiply by 2x, right? And now I will simplify the numerator. Okay, so here I have simplified the term, and then I have gotten the same differentiation which we got from the quotient rule, right? So now let's see another example, number 3. I have taken different example because concept is same, but when questions is asked either in root form or in fractional power, students usually get confused. So I have tried to consider here all 2-3 types of cases so that you can be, or you are able to solve the exercise on your own. Okay, so my next question is this, and I have to differentiate it, and I will apply quotient rule because I also want to teach that also. I want the students to know, but if you don't want to apply quotient, you can apply product rule. So coming back to it, this is my u, this is my v, and this is my quotient formula. V u prime minus u v prime over v square. Okay, so I am writing my u and v here. Here is the u and here is v, and I will differentiate it. So 2 3s are 6, 2 minus 1 is 1. Now you must know that this square root symbol, which is called radical symbol, when you remove it and write it in the index form, the power is half. Okay, so basically I can say that this means this function has a power half. So when I will differentiate, that half power will come here as a multiplier, which is here, and then half minus 1. Function will remain as it is right now, and then multiply by the differentiation of the function inside the bracket, which is 2x square minus 3. So it will become 4x minus 3. After that I am simplifying it. This 4x is coming here. Half minus 1 is minus half. Usually we write in the positive index form, so I am taking it in the denominator. And half mean radical sign. So this is my u v prime v u prime. And now I am going to substitute these values in the quotient formula. So here is the quotient formula, and I will substitute those values. So here they are. Simple substitution. I am not simplifying or doing anything. I am simply substituting the values. And after that I will simplify. Now these type of questions look little difficult to the students, and the reason is in the fraction there is another fraction in the numerator, right? So now you have to be careful, leave spaces in between properly so that you can understand what you are doing. Otherwise at times the students are unable to read their own steps, okay, what they have written and why. So the denominator here is 1. I'm talking about only numerator right now, okay? So this side will multiply by this because the denominator here is 1. So when this will multiply by this, I will be left with 2x square minus 3, and 6x is here, minus 3 to the 6x cube. So I have written numerator, I have taken the LCM of the numerator and written here. Now this denominator, which was v square actually, so 2 and this half will cancel out, so I will be left with this. Now before I go further, I would like you to recall the concept which you have done in the previous classes, maybe in class 8 or 9. If there is a numerator which is in algebraic form, which is in fractional form, for example a over b over c, this means a divided by v, b divided by c. If I'm writing it horizontally, this is written vertically. And when we change division sign into multiplication, the term after this is reciprocal. So C will become 1 over C, which means A divided by B and C, B into C. So it means simply this is coming here. So exactly the same thing I will do here. Now this denominator will come here as a multiplier, and the logic behind it is this, right? ये खुद से नहीं उठ के आ रहा, it is because of this reason. So now this is here. So now I'm opening this or expanding this numerator, which is here, right? And then I got this. So this is my derivative of the function. I hope you understood. Now let's see the last example of quotient rule. Okay, so in this example we have to differentiate. Question is saying find dy over dx, and then we have to find the value of the gradient at x equals to 1, because when we find dy over dx, the function we get is actually a gradient function of the original function which we are differentiating basically, right? So only one step extra. When we will differentiate, we will plug in x equals to 1 also. Now what does it mean, why we are plugging in? I'll try to explain you through graph. Okay, so now look at this function which is here. So this is my u, this is my v, and we know this is the formula for the quotient rule. So now my u is 3x square, the differentiation will be 6x, and my v is 1 minus 4x square, so the derivative will be 0 minus 8x. So I have all the derivatives here, and now I will plug in the quotient rule. So I have substituted the values here. This was my v, so it is v square, v u prime minus u v prime. So I will simply open the numerator now, or expand the brackets, and this is what I will get. Okay, so this is my gradient function, right? Now question is saying find the gradient, find the value of dy over dx at x equals to 1. It simply means on the original function of this function, when this function has the point where this function has x equals to 1, what is the slope there? What is the rate of change there? So with the help of this gradient function, I'll substitute the value x equals to 1 and get 2 over 3. So let me explain to you graphically, and again I will use Desmos to explain the concept. There are many other software also, online free software, which help you to get the graphical image of any equation, but I like using Desmos, so I will just explain it to you or show it to you through it. Okay, so here is the Desmos. Just showing you, I have written down the equation y equals to 3x square divided by 1 minus 4x square, and this is the graph I have gotten. Looks very strange, you might have never drawn such graph, right? So what is the meaning of the question? This is the graph, and graph was saying find the gradient at x equals to 1, right? So if you look at the graph closely, x equals to 1 is somewhere here. So at this point, if you draw tangent, it will be somewhere like this, right? So the line is not very steep, and that's why the gradient we have gotten is perfect, which was 2 over 3. So this is the meaning that at x equals to 1, what is the rate of change of slope here? So in maths, we used to draw tangent line like this and used to get 2 points on it, and then gradient formula, which was y2 minus y1 over x2 minus x1. But here the differentiation has made life much easier. I can, after finding the gradient function, I can find the gradient of the curve at any point just by substituting the value of x in it, right? So you can also look at the shape of different graph and you make your concepts clear. So at this I will end the video, and thank you very much for watching the video. I would like you to press like if you have learned something from it, and subscribe it, and do give your comments, whatever you have felt while you are watching this video, anything which I can do to improve making my videos. So I will really appreciate it. Thank you very much. Bye bye.